Okay, we are going to start deformation, elastic deformation. Okay, now what is a deformation? You can understand it by the name. Deformation is a change in shape or size due to the external forces. So state that a force may produce a change in size, shape of the body. So due to the effects of the forces, we have a final change in the body due in the shape, size, or the speed. Okay, a change in shape is due to applied force. This can be the result of tensile pulling force or comprehensive pushing force, steer, bending, or torsion. Okay. Uh, tensile pulling. Tensile mean pulling. These are the types of forces. Compressive pushing forces. When we are trying to push anything, or when we are trying to pull anything, these are all types of forces we are applied on any body. Any bending, if we are bend any object, we torch or twist any object, these all are actually a type of forces. If we applied any such forces on a body may change its shape or make permanently change its shape or make temporarily change its shape. So what is the, if we talk about deformation types, but we have two types, elastic deformation and plastic deformation. Okay, so what is deformation? There is a change in shape or size, change in shape or size due to applied external forces, whatever it is, pulling, pushing, shear, bending, or torching, or twisting. Okay, whatever, which of the forces applied, a body may be changed its size or shape, right? And there are further two types of deformation, elastic deformation and plastic deformation. Okay, now what is the difference between the elastic and plastic? I'm showing one video here, a different types of elasticity. Okay, if we are applying a force on any object, suppose here we are compressing our spring, here we are stretching our spring, and here we are trying to bend it. So these are different types of forces we are applying. Similarly, we can apply these type of forces not on the spring only, we can apply it in different objects, like kick a ball or touch a mobile. Okay, spring having elastic property, it can easily show the deformation. But if we talk about other objects, these are less elastic, right? So it is more harder to notice, is there any change, or is there any deformation, is there any change in shape, or is there any change in size of object if we are applying a force on it. So that was quite harder to notice any change. Okay, the forces may be of many types at a single point. It may be compressed, stretched, or bent at. And you know very well that whenever you apply any force on object, right? So opposite force will also be active. Suppose if you are applying a force downward direction, so the object is actually applying a force in the upward direction against this force you are applying, and both are of the same magnitude. Okay. Okay. As I have discussed with you that there are two forms of deformation. Number one is elastic and number two is inelastic or plastic deformation. Okay, you can see here in elastic deformation, we are taking a spring and when we apply the force, it gets stretched. But on the other side, we have inelastic deformation, means when we are applying a force, a body get deformed. You can see it is get permanently deformed. But what about the spring? It is get its original shape after we have applied force. It can change the shape. But as I removed the force, it comes back to its original shape. So this type of forces are called elastic deformation. Okay, right? If I apply the forces, it gets deformed. But as I remove the force, the body gets its original state or its original shape, right? So these are elastic deformation. What about the inelastic deformation or plastic deformation? When we apply a force, it gets permanently destroyed, right? So that is inelastic deformation. So further we have two types, elastic and inelastic deformation. It is cleared. Okay. So we have done that what is the deformation and what are the two types of deformation, elastic deformation and elastic deformation, right? Okay, now we are trying to do one practical with it to understand it more. To study the deformation of spring, we need some of the instruments like a spring, 100 grams plot of mass, meter scale, resource stand. So how can we do it? Let's see. So we need a one stand, one spring, one mass, and a meter. So we have to arrange the instruments like this. We have to measure the unstretched spring. First of all, we have to measure the length of spring without mass. Basically, without the mass, we have to do it without this. So we have to find out the length, first of all. Our first step to find out the length of unstretched string. This one is a stretched one, right? So it may be like at that point before it is stretched. So we have to find out that length first of all, then measure the length of the stretched string with the mass. Number two step, then we have to find out the length of the spring with the mass. Okay, when the spring gets stretched. Now we have to repeat this procedure again. Okay, first of all, we need to find out the length of without the stretched string, without mass. Suppose it is 10 millimeter. Then we will attach a 1 Newton mass in it and find out the length of that string. Again, we have increased the mass and now we are going to find out the length of the string. It will be increased gradually as mass is increased, right? If I increase to 1 Newton mass, so I have there is a change in 10 millimeter. Again, when I add up one more mass, means 2 newtons, you can see there is a gradual change that is 20 millimeter. The load force. So actually this load is acting like a force because आपको पता है कि जो force यहाँ पर है that is because of the weight and weight is equals to the forces. यहाँ पे जो downward force है that is mass, the weight of mass you are attaching here, right? And you know that mass is equals to the force. This load is actually equal to the force due to the gravity. This weight, this load is actually a force due to the gravity because it is acting in the downward direction. Am I right? It is acting in the downward direction. And as the mass increases, that means the force will be increased. And you can see there is a change in length, right? So load for every mass is 100 grams. 1 Newton here is actually equal to the 100 grams. And you know that W is equals to mg. F is equals to mg. Or F is equals to mg. Am I right? So you people are well aware about this formula. The extension of spring is the difference between its stretched and unstretched string. You can see the difference, a major difference there. That a spring without any force or a spring with the different forces. So you can see that there is a gradual change, a linear change. How much the load you have added, there is a gradual change in the length as well. Is that clear, everybody of you? Your camera is again off. Azan.
Yes, miss.
Saima. Saima. Tell me, is everything clear?
Yes, miss.
Sufyan,
Yes, miss. Clear.
Mera, Zoha. Yes, Zoha, Zoha Kureshi. Is everything clear?
Yes, ma'am.
So here is a graph. You can see with the graph that this graph is against extension and load. Load means the mass we are adding, and extension that is the change in length of a spring. Okay, So extension is actually denoting Q the length. Extension is denoting Q length L. Okay. And load is denoting Q force that you are adding. Force or weight. Right. So you can see the other, what is the graph between both of them? You can see that there is up till here there is a straight line. Up till here, X point, we have a straight line from 0 to onward. What does it mean? Can anybody of you interpret it?
The graph is linear.
Yeah, the graph is linear. That means as I added weight, a linearly length will be increased. But what is it? What happened after the X point? Why there is a not linearity right there? Can any of the idea? Why from here, from X point, now the graph is not linear. Yes. Any idea? That why a graph is not linear?
It can't be extend more.
Yes. So it can be extend more, but after we are adding more weight, it will permanently deform. Means if I remove the weight afterward, but my spring is not regain its shape again. After that point, X. Up till here, when I'm adding the mass more, and if I remove the mass, before that point, my spring regain its shape. But after X point, if I added more weights, now my inelastic property of spring is permanently deformed. Now my spring is not regain its shape and it is get permanently deformed. ऐसा होता है ना कि जो अगर आप एक स्प्रिंग को दोनों हाथों से खींचना शुरू करो, एक पॉइंट होता है आप उसको रिलीज करो अपनी जगह पर आ जाता है, लेकिन आप इसको और स्ट्रेच कर दो और मूव कर दो, अब वो डिफॉर्म हो जाते हैं, कंप्लीटली डिफॉर्म हो जाते हैं। और वो पॉइंट होता है जहाँ पे इसकी इलास्टिक प्रॉपर्टी खत्म हो जाती है, इलास्टिक प्रॉपर्टी स्प्रिंग की खत्म हो जाती है, लिमिट क्रॉस हो जाती है। The graph is divided into two parts. The graph slope up speedily. This tension increase as load increase the load. Okay, the second point is the graph bends here upward. If you are adding a load greater than the spring constant, now the spring become permanently magnetized. Okay. जैसे हम कहते हैं हर इंसान की कुछ लिमिटेशन, राइट? जैसे हमारी कुछ लिमिटेशन है कि इतना तो हम बेयर अप कर सकते हैं किसी का एटीट्यूड, बट आफ्टर दिस माय लिमिट्स क्रॉस, इससे ज्यादा नहीं। जैसे हम कुछ लिमिटेशन सेट करते हैं, सिमिलरली हर ऑब्जेक्ट की, हर मटेरियल की भी लिमिटेशंस हैं। These are the natural things. इसमें कुछ गलत नहीं है। A person should have limitation, right? इसमें कोई गलत चीज नहीं है, because the nature has set some limitations for the materials of stuff. हमारी नेचर ने हमें लिमिटेशंस दी, हमारी नेचर की तरफ से लिमिटेशंस। So why we bear a lot of stress from the surrounding? We should set some limitation, right? बिल्कुल इसी तरह मटेरियल्स की भी लिमिटेशंस है। अगर हम उन मटेरियल्स को उससे ज्यादा स्ट्रेस अप करेंगे, उससे ज्यादा फोर्स करेंगे, देन इट विल ब्रेक, टूट जाएगा, राइट? और यहाँ पर भी यही हुआ है कि जब हमने उस पर एक्स्ट्रा फोर्स अप्लाई की जो उसकी लिमिटेशन से ज्यादा थी, और स्प्रिंग आपका परमानेंटली डिफॉर्म। ये कुछ आगे आपके पास इसकी प्लॉटिंग भी है और एमसीक्यूज भी हैं, न्यूमेरिकल्स भी हैं. इसको हम बाद में प्रैक्टिस करेंगे. दैट इज रिलेटेड टू द Hooke's law. We will do it tomorrow. Okay, but now we are trying to analyze this graph. It will be now clear to you that before the x point, it has elastic limit. But after the e point, x point, now its limits get crossed, and now our spring is not regain its shape again because of a lot of stress, a lot of gain load attached, right? As you can see, if I added a mass of 1 Newton here, and if I remove, the spring regain its shape, right? Similarly, if I add 2 Newton force, again my spring can get its original shape. If I get 3 Newton force, again my spring can get its original shape. But if I double the load, 4 Newton load, now you can see the spring is get deformed, and that is the point where my graph is not linear. Now that is the point where the spring lose its elastic property. Now it will no more elastic. So that is the conclusion. Line is straight and passes through the origin. Every 1 Newton mass is increased in the load to produce the same extra extension. If the load is doubled, now the extension will be doubled. An extension that means the load always have the same value. So what we have concluded from this graph, and we can see here that after the limitation, my graph is get deformed, and that is the point where my graph is crosses its limitation, that is elastic limitation. Up till that point, my spring has elastic property, and it can regain its original shape. That is the original shape. Till 3 of this stage, it can regain its original shape. But at that point, that is the point where my spring is get deformed and it's not able to regain its original shape. Clear? Okay, now tell me, is it clear to all of you up in here?
Yes, ma'am.
Okay. So we have done up in here in today's class, and we will discuss remaining in the next classes. So what's your homework we have to go through from this lecture of today? That's it. You can get practice of data, memorize it, keep in your mind. Okay, so we are ending up our class here.